role in engine operation, and lifespan engine oils for primary functions include lubrication, suspending contamination, dissipating heat, and acting as hydraulic fluid for internal engine components. Lubrication represents oil primary functions inside the engine. Moving parts generate friction oil, reduce friction between these surfaces by creating narrow film of oil moles. Oil film reduce friction and heat. Oil also isolates the suspected harmful contamination between oil changes. Suspending these particles every oil change flushes the damaged material out of the engine oil. Also protects against rust and corrosion by coating the internal engine parts, preventing oxidation. As oil flows through the engine, it also removes heat from the friction points, isolate from the cooling system. Finally, vehicles use oil as hydraulic fluid engine, such as components as VTEC, rocker arm, VTC, and cam chain tensions. In order to lubricate all the moving parts in the engine, all oil systems use common components. A typical system used a pump to move pressurized oil through the engine, and gravity returns oil back to the engine sump to circulate through the engine. Again, this section will relieve these components. The lubrication system uses a positive displacement oil pump, pressurized engine oil passages, some parts amount of front crankshaft, while other engines drive using a chain connected to the crankshaft. The pump assembly includes the relief valve, designed to limit total system pressure. The relief valve opens if oil pressure exceeds spring pressure due to the low temperature. A block in the oil passage when the relief valve directs oil back to the oil pan. From the oil pump assembly, oil flows to a oil filter. Inside the filtration media traps contaminations such as dirt or material particles. If allowed circulate in the oil system where contaminants may be the product of combustion or an internal competent product. Combustion includes soot, carbon, particulates, unburned fuel, and water when oil remains in the engine too long. This contamination overload the oil assembly in the handle of the forms coating called sludge, and sludge over internal engine parts blocks return path to the oil pan and reduces lubrication performance internal. Contaminants consist of metallic particles, spent oil, advanced sulfuric and acid, nitric, and these contaminants increase wear of moving parts, leading to the engine friction, reduce oil pressure and components. Some contaminants can plug the media inside the oil filter. When this occurs, the oil filter allows less oil to flow to the engine and reduces oil pressure. To prevent a blocked filter from starving the engine of oil, oil filter includes bypass valve should the friction media block too much oil. For the bypass valve opens, allowing the unfiltered oil pass to the block, while the oil filter remove solid contaminants that engine from crankcase, positive crankcase ventilation or PCV system remove gases contamination. This contamination includes combustion gases and leak parts, pistons, rings. Consideration: the PCV system draws in, filters air, and uses engine vacuum to send crankcase vapors on the combustion chamber. The reduced sludge formation and helps increase the engine oil life. Some engines uses an engine oil cooler at the transfer filter to transfer heat into the cooling system. One coolant line delivers coolant in the oil cooler, while second line sends the coolant in the heat into the engine water jacket. From the oil filter, engine oil travels through oil passages, manufacturers machine engine parts that oil passages match up to components because of the always considered oil passages when positioning gaskets during engine assembly. In some cases, an oil passage includes an oil control orifice. This device reduces oil flow when installed in oil passages whenever you disassemble an engine. Keep track of the orifices. If you replace a block, be sure the new block has correct oil controls orifices, or transfer the oil orifices the original block to the engine. Before reassembly, must oil pressure and at bearing be typical include wear surfaces, recoating component and bearing surfaces.
Engine lubrication by means of oil is primarily used to reduce friction between moving parts and dissipate heat. In this animation, we want to describe wet sump lubrication using a 4-stroke engine with only one cylinder. In the lower area of the engine is the oil sump in which the oil can be found. The oil pump is responsible for pumping the oil through oil galleries. When the oil has become very hot after several cycles, it is cooled by an oil cooler. The oil is then pumped to the oil filter. Inside the oil filter is a filter that catches the particles in the oil and does not allow them to pass through to the engine. The oil flows from the outside into the oil filter, then runs through the filter, which is made invisible here, and flows through the center tube. Then, the oil flows upwards. The oil flows to the engine where it is used to lubricate the crankshaft bearings. In 4-stroke engines, crankshaft bearings are almost always plain bearings. Unlike roller bearings, which use roller elements to move the inner and outer ring against each other, plain bearings use oil to form a lubricating film. The lubricating film is created by the two contact surfaces that move. The crankshaft has oil galleries so that the connecting rod bearing can be supplied with oil. In diesel engines, the connecting rod can also have an oil gallery to use the oil for cooling and lubricating the piston and the piston pin. For gasoline engines, on the other hand, the oil, which splashes out of the sides of the bearing, is used to cool and lubricate the piston, pin, and cylinder. Holes can also help to transport the oil to the desired parts and spots. The piston has one or two compression rings and one oil scraper ring. The oil scraper ring is responsible for controlling the oil balance at the piston and the compression rings. Excess oil flows inwards through holes, especially when the piston is running down. Then, the oil can drain down from the piston into the oil sump. Furthermore, the oil is pumped to the camshaft bearings, rocker arms, and valves in order to reduce friction and heat. From here, the oil flows into the oil sump via oil galleries.